Hello everyone, this is Kevin Jones from PCI Geomatics. Welcome to the webinar. We are going to be starting in just a few minutes. We just want to give people a little bit more time to get registered in or get logged into the platform for the webinar. So we're just 2 o'clock right now, but we'll give it maybe 1 minute or so until we start the broadcast or start the actual presentation. All right, well, once again, welcome everyone to our webinar entitled Aerial Processing Workflow of Phase 1 Industrial Imagery, which we're really happy to be presenting to you today. So to give you an overview of what we'll be presenting, we're going to be providing you an introduction to Phase 1 imagery and PCI Geomatics as a company and our software very briefly. Then we will get into the concepts and best practices to process aerial imagery using PCI software and together with Phase 1 industrial imagery, which we've been processing for this particular webinar. This will include all the steps, including data ingest, aerial triangulation through tie point collection and refinement in GCPs. Then once we do that, we'll be talking about extracting digital surface models, filtering those to create digital terrain models, DEM editing, ortho rectification, mosaic generation and mosaic editing, and so on. Presentation is going to be broken down into both PowerPoint and live demonstration. So I will be the one giving the PowerPoint portion or the explanation portion, and then that's going to be filled in by Jason Flatt, who's standing by to give a live demonstration of the software. We will do a Q&A at the end. However, if you see something and you're wondering and you have a question, don't hesitate to type it into the question panel. Once we get going here, there should be a panel for you to write questions in anytime you see anything of interest. So just a quick note on the presenters. So myself on the left, I'm the Director of Marketing here at PCI Geomatics, and Jason Flatt is one of our technical solution specialists. And so Jason works with our clients around the world, basically providing expertise to ensure that the software that we provide meets the needs that the clients have in terms of the workflow that they're trying to complete, whether it's with optical imagery or other types of imagery or specific types of applications. So Jason is one of our experts on using our technology, and he'll be doing the live demonstration. All of the lines are muted, so you can have a conversation. If you're sitting in a room with somebody else and you want to talk, you're not going to be bothering anyone, that's fine. You can type your questions in the questions panel anytime. If you do want to speak to us and you're connected to a computer that has a microphone setup, whether it's a USB headset or you're dialed into the telephone call, then by all means, raise your hand, probably in the Q&A session. We can unmute your line and you can talk to us directly. We will be sending a recording, we always do, so we're quite good at that. We'll probably turn that around within the next 24 hours after this webinar ends. Just a few quick words about PCI as a company and our technology. So this really nicely illustrates a lot of things about our company and about our technology. Essentially, what we like to say is that PCI offers a platform for processing imagery, for geospatial image processing. And that platform includes Geomatica on the left, which is more of a desktop software tool. And then we have GXL on the right, which is more of an enterprise workflow-based tool or software tool that allows you to deal with higher volumes of data. In the middle between all of this is some glue that is common to both Geomatica and GXL, and that's our Geomatica API, which is a Python-based API, which allows you to automate workflows both at the desktop and at the enterprise level. So depending on how much operational efficiency you're looking to achieve, how much data you're processing, and how much budget you have, then basically what we're saying with this slide is we have a solution for you that can be custom made for your budget and your requirements. So another quick slide just to introduce PhaseOne Industrial. So we started talking to PhaseOne Industrial recently. The company is an organization that's dedicated to research and developing aerial solutions. Today we'll be focusing on one of their medium format camera, which is the IXU RS1000 series. It's suitable for small to medium size aerial mapping, urban mapping, and 3D city modeling. Here's a picture of what the PhaseOne camera system looks like for aerial. It's a 100 megapixel sensor. You have a choice of lenses ranging from 55 to 240 or 32 to 150, depending on the type of lens that you're going with. They offer two different options. Both NIR and UAV capabilities are possible. So it's possible to add the proper filters for collecting NIR, and it's also possible because of the lightweight nature of this camera system to mount it on a UAV for using that kind of a platform for collecting imagery. So we always like to engage with our audience when we do these webinars. So I'm going to launch a quick poll just to get a sense of the type of imagery that you're working with. That's our first question. So let me go ahead and launch that. So we'd like to know if you are working with aerial imagery today, what type of imagery are you working with? Is it PhaseOne Industrial? Is it UltraCam? Is it ADS frame camera, such as RCD30, or possibly it's ADS pushbroom camera, such as the ADS 40, 80, 100 series of cameras? Or possibly you're working with a UAV platform. Of course, we all know that those are quite popular these days, and could be that you're using a UAV camera. So we're curious to know what you're using. Just going to leave that open for a few more moments. Looks like mostly everyone has voted. So I'm going to close that down and just share quickly the results with you so you can see that. Kind of interesting. A lot of people using UAV platforms. After that, it's PhaseOne, then UltraCam, then ADS pushbroom, and then ADS frame camera. So interesting results. Thanks for sharing those with us. So if I go back to the presentation, I'm just going to talk a little bit about our aerial production solution. So we offer a complete package to perform aerial data processing. We have, as you can see, a number of products that can be generated through our package. Everything from digital surface models to digital terrain models. Then we can use that digital terrain model to create a digital terrain ortho image, or in the case of highly overlapping data, we can actually generate a DSM True Ortho image and generate a true ortho image from that. And then of course the ortho mosaicing processing that's possible with both the DTM and the DSM Ortho. I'd like to show this slide because this is something that we see quite a bit. We do visit with many of our customers and we find out what their solution currently looks like. And you can see the red arrows and the blue arrows kind of indicating that there's a cycle typically in the processing of aerial imagery or satellite imagery for that case. But essentially, a user would typically start by ingesting raw data. They would use exterior orientation, otherwise known as EO, and camera calibration to start the aero triangulation process, or use the existing EO and camera calibration as the final point for the aero triangulation. Then they would either use an external DM or extract a DM from the stereo in the data. And before going to the ortho step, they would basically inspect that DM to ensure that it doesn't have any major blunders. It's not going to cause any artifacts in the ortho imagery. Once that's done, customers typically would generate orthos. Then they would inspect those orthos. And where there are problem areas, it's most likely due to, if it's not due to alignment, it's definitely due to the elevation model. So then they would make the edits to that model, possibly in a 3D stereo photogrammetric environment, such as DTM Summit Evolution, which is one of our partners. So maybe they would make edits in that kind of a platform. Then they would regenerate the ortho and so on. Once they reach that step, once they complete that step, they would move on to generating a mosaic from the orthos. And once again, there's an iteration that would typically happen where customers are having to fix problem areas. It could be things like fixing seam lines, but it could also be in the touch-up stage, in the very final stages, where you have overpasses that are problematic, or bridges that are problematic, or basically areas where the elevation model has some potential errors. Then those would be touched up using possibly a tool such as Photoshop. We've seen many of our customers do that. So our philosophy at PCI is to try to streamline this entire workflow and just make it a lot more straightforward. So you can see that we have ingest, exterior orientation, camera calibration. Then we can add the aero triangulation. So in addition to the aero triangulation that's been provided externally, we can improve upon that by collecting tie points and GCPs. Then we can either use the external DM or extract the DM ourselves. And as you'll see in the live demonstration, rather than generate orthos and then inspect them, we actually generate what are called live orthos. And what you're seeing on the bottom is actually a bit of a QA trick that we've implemented, where you can flicker back and forth between two different overlapping ortho images. And anything that's not moving on the ground basically is indicating that the model is strong, and also that the elevation model that's being used, in this case the digital terrain model, is not causing any artifacts on any of the buildings. Once we've inspected interactively using the Live Ortho tool, we would move to the ortho step, and then we would generate the mosaic. Now the mosaic, as you can see in the middle part, we have this cut line running down the middle of the water, and what we're doing is we're interactively adding what are called dodging points, edge dodging points in this case, along the seam line in the water, and we're blending the two sides of the seam line with each other. So we have different methods for doing that interactively. And once again, it's only a preview of the final mosaic, so it's very interactive. The final step, in the touch-up step, we have a very simplistic case here. It can be used for many other things, but in this particular case, we have an overexposed building. As you can see, it's very, very white. So we can draw a polygon around that particular building. We can reduce the overexposure and create and give more dynamic range over that particular building. All of this is interactive. It doesn't require rework, and is, in our opinion, it's just a little bit more streamlined in terms of the processing workflow. I do want to highlight that we offer a flexible platform for processing aerial data. However, there are some differences and some recommendations that we would give you depending on what it is that you're trying to achieve. So if you are planning to generate DTM Ortho mosaics, you're fine to use GXL, but we would definitely recommend that Geomatica would be better suited for DTM Ortho mosaic production. And in the case of DSM True Ortho, which is where we have highly overlapping imagery that's been collected, lots of forward and side lap, then we have some specific optimization that are part of GXL that are really going to take advantage of specific parameters for processing the data to ensure that when we create the DSM True Ortho, then we have fewer blunders and fewer artifacts in the data. So we highly recommend that you use, if you're going to be generating DSMs from the stereo in the data and you plan to use those for making DSM's True Ortho, GXL is the best place to do that. If you're planning to generate DTM orthos, then you're for sure going to be successful in either GXL or Geomatica. So we just want to make that clear separation. So we're going to start with the Aerial DTM Ortho Mosaic workflow. So here we have a PhaseOne project that we worked on, and you can see that in this case it's highly overlapping. A long track overlap looks to be something in the neighborhood of 80 to 90%, and the across track overlap is definitely 60% or more. So we have 80-60 overlap in this case. So this is actually a suitable data set. We can choose to do DTM ortho or DSM ortho in this case. So as Jason will show, he will actually process a subset of this data. It would be too long in this webinar to process the entire data set, but we were provided initial exterior orientation information from which we built upon. So here you can see the tie points that have been added on. So these are multi-ray tie points that have been collected across the entire block. You can see they're very well distributed. And as Jason will show, the RMS is quite good, definitely sub-pixel and suitable for generating high quality products. This is an example of the DSM that's been extracted from this data set. You can see that the buildings are quite clean. The building edges are also very clean. And it's just in general very, very nice looking product. So this is the type of product that we're able to generate. I believe this is 4 centimeter ground sample distance in this particular instance. Jason will be showing you the actual data or part of the data. From there, we can apply automatic filtering. So we do have automated methods to remove surface features such as buildings and vegetation. And here we have what's left, which is the digital terrain model. And from that, we can use that to generate the DTM Ortho Mosaic. So that's what you see on the screen right now. We do have this interactive tool. So a couple of things to note. The DSM to DTM filtering on the left is a specific module that's been developed in Geomatica. Here we're showing the module in the algorithm librarian, which is available in Focus. However, you could call this tool at the Python level or in other parts of our software, but it will basically iterate through the DSM and remove objects based on the size that you wish to remove, the gradient, the type of terrain, and you can iterate through a data set and basically automatically remove a lot of the terrain. Then you could go to the live ortho tool, as Jason will be showing, and you could inspect what the orthos will look like based on that automatic filtering that you've created. And based on that preview, you can then make additional edits, interactive edits, and see how those edits affect the final ortho mosaic. So once again, that's the streamlining of the entire workflow by having these live ortho preview tools that allow you to see how the final product will look before you generate the final product. This is an example of a highly overlapping data set. In this case, I believe it's UltraCam. You can see a very high quality DSM has been generated. And then we ran the DSM to DTM filtering algorithm on it to remove all of the surface features. So very easy to do that. It's an automated algorithm that will remove the vegetation and the buildings for you. Those manual touch-ups that in some cases are required are available through the DEM Editor, which is in Focus. And here you can see the pull-down menu where you have the option to apply a variety of filters to address multiple use cases in terms of fixing elevation. So Some of these filters are suitable for fixing bridge overpasses. Some of them are more suitable for flattening a road. Some of them are suitable for retaining an edge along a steep cliff, so you can insert break lines and things like that to preserve the elevations. So that's the tool that allows you to interactively make edits and then see what those edits will do in terms of the resulting product. Just a bit of an interactive look at the same tool. So here we can draw a polygon and target a specific area. We can apply a specific filter. So we've pulled down the terrain filter flat. We've asked for any surface object that's 400 pixels or less, and a gradient that's 10%. And then it's basically going to remove that. So if I go to the next slide, then it essentially removes all of the features that match that criteria. In 2018, which is the current release of the software, we have improved this live ortho preview capability. We want to simply differentiate the previous version. So in 2017, a user would have to interactively select an area, or would have to select an area of interest where they want to preview at 1:1 resolution the ortho based on the DEM edits. So you were limited in terms of the size of the area, or I mean, the tool was basically meant to target smaller areas. In 2018, we actually have a live ortho preview capability across the entire data set. So this will actually regenerate the orthos on the fly for all of the images in the project. So it makes it a little bit easier to work across the entire data set. Here's what the tool looks like now. You can see there's this new icon, which is the live ortho preview. So you basically select the live ortho preview, and then what you can do, you can see that we didn't have to select an AOI in this case. It just generates the live orthos based on all of the possible ortho images that overlap the DEM. And then you can filter, or you can, cycle through the different orthos. So you could just kind of work your way through. Jason will be showing this. You can work your way through the different options. And once you find the right one, then you can choose that for your final mosaic. So I'll pass over to Jason at this point, who's going to jump into a live demonstration.
Thank you very much, Kevin. Hello, everyone. For this demonstration, as Kevin mentioned, I will be demonstrating and showcasing the full Geomatica workflow as presented by Kevin. I will demonstrate how a user can prepare a new ortho engine project, ingest the raw PhaseOne imagery, improve the aerial triangulation of the model with ground control points and tie points, extract a DEM, edit and filter the DEM to then generate the ortho rectified imagery, and then produce the final DTM mosaic. So first, I'm going to open up PCI's photogrammetric platform for aerial and satellite processing called Ortho Engine. Once it opens up, give it just a second. There we are. Now we can create a new project by going to File, New, setting a file path name. We're going to call this one Webinar. We're going to give it a name, calling it PhaseOne. And as we are working with PhaseOne imagery, I'm going to select the aerial math model and choose the digital camera type. And since we're going to be improving the aerial triangulation with GCPs and tie points, I'm going to keep the exterior orientation, compute GCP and TP option selected and click OK. I will then set the output projection that we're going to be working with. For this data set, it's going to be in UTM, WGES 84, zone 36. And here I can set the zone at 4 centimeter resolution. The survey GCPs that were used for this project as well are also collected in the same projection, so I can just set the GCP projection based upon the output projection and click OK. Now that I have set the projection, I can then input the camera calibration information. We already have the camera calibration information visible in this notepad provided by the data provider, and I can input the information in one of two ways. The first manually inputting all the information in their associated inputs. Or if I have it as an XML file, I can easily import the file. So I'm going to select Input Data, Camera Calibration, and automatically all the parameters are set as it read through the XML file. And click OK. Now I can go to the next processing step. So actually, the Ortho Engine interface is set up with a drop-down list of processing steps that the user will go through sequentially, and depending upon the workflow that they are going through, they may make use of all or just a few of the processing steps. So for our next processing step, it's going to be the data input. Here we can load a new or existing image. So I'm going to ingest the imagery. I'm going to select all the images. We can either add the original TIFF file formats or our own PCI file format. And just for ease of processing, I'm going to load our PIX files. All the images have been loaded. And as PhaseOne imagery actually contains associated EXIF tags, our system is capable of reading the X, Y, Z, omega, phi, kappa for each image. As such, I do not need to go to our next operation, which is importing an exterior orientation file from an external text file. If I was working with other imagery, such as UltraCam, I would need to import an EO file supplied by the data provider. So we can view our project overview to see the distribution of our footprints. We have one single flight line of imagery, and we're going to be processing that. Now, everyone, if we can remember what this type of distribution looks like, because after we collect and improve the aerial triangulation, we will see some differences. Now, after I'm going to go to the next processing step, which is our GCP and tie point collection. Here, we can collect automatically or manually ground control points and tie points and utilize a residual report to view the overall summary of the absolute and relative accuracies of the model. But for purposes of this webinar, I'm actually going to go to another project file that I've already collected the exterior or the tie points and the GCPs, where I've already improved the aerial triangulation. So here is the project that I've already collected. I'm going to go to our GCP and tie point collection. I'm just going to move. Oh, I won't move that right now. And we can go to the View, Project Overview, and see already that the footprint distribution is significantly different as I've improved the model with the tie points and ground control points. And I can go to the right click on the images, show tie points, and we can see that there's a good distribution across the bundle of images. This area is missing tie points because it's actually water, so it's good that our system did not collect any tie points because we'd have to remove them. I also collected an additional survey ground control points, collected them at stereo due to the overlap, and they're distributed across the model. So I'm going to close, and I can now open up the residual report, and we can see a summary table of all the ground control points and tie points within the model and their overall absolute and relative accuracies in RMS. We also have access to all the individual points in the model and their related residual errors, and we can either remove or by deleting or just inactivating all the points and recomputing the model to help improve our overall aerial triangulation. As Kevin mentioned, we were able to get our overall relative and absolute accuracies below 1 pixel, so we have sub-pixel accuracy. So now we can continue to our next operation step. The next operation is our DEM from stereo. As the imagery was captured with stereo overlap, we can leverage our two-step DEM extraction process to extract the DEM. The first operation is creating epipolar images. The epipolar generation tool aligns the stereo pairs by removing the Y shift so features are lined up in the x-axis. This will enable the system to run the elevation triangulation in the DEM extraction, which will generate, filter, smooth, and geocode the epi-DEMs, then merge them all together to form one single DEM. So here's the window to create the epipolar pairs. Once created, we can then extract the DEM automatically. Here we can choose the extraction method. We can select all the epipolar pairs. So I'm going to select all. Choose the extraction method we want. The sampling interval we're going to set to 1:1, so we can then extract a DEM at 1:1 resolution, so 4 centimeters. Create the geocoded DEM. We're going to browse to the output and we're going to call it DEM Webinar. Set the output resolution to be 0.04 or 4 centimeters. And then we can extract the DEM. Now again, for the interest of time, I've actually already extracted the DEM, and we can open up our focus window to view it. Here we see the DEM I've extracted. Now it is important to note that we are working with a single flight line again, so we cannot make DSM True Ortho imagery, and we're going to need to remove all these blenders and surface features in order to produce our DTM for ortho rectification. Now, before I filter, I would like to perform some DEM editing to this bridge near the bottom of the DEM. I want to maintain this bridge in the DTM, so I'm just going to remove some of these artifacts underneath the bridge. To do this, I'm going to make use of the DEM Editor tool and the Live Ortho Preview tool that Kevin made mention of previously. I'm going to open up the Live Ortho Preview. As Kevin mentioned, this tool will enable us to visualize the ortho images that will be produced from the working DEM. And we can see that there are a number of blunders due to the DSM, but we're going to ignore all the buildings and the trees and just focus on this one bridge. And as we can see in the derived orthos, and we can cycle through all of them, that there is this blurring underneath the bridge. To get rid of this, we can leverage the DEM editing tool. I'm going to create a DEM editing polygon layer and create the polygons. I can do this in two ways. I can either A, do it within the focus window on the DEM, or I can use the Live Ortho Preview to create the polygon. I'm going to produce it one in each. So the first time, I'm going to make one large polygon just around the road. And we'll see why I'm doing this in just a second. So I have one single polygon. And then I'm going to go to the Live Ortho Preview. And of course, as I'm moving, I can scroll across the whole project and the ortho images will be generated on the fly. I can then create the second polygon along the bridge. I'm just going to follow this bridge to the end. Wonderful, I've created two of our polygons, and the polygon we just created in the Live Ortho Preview is represented in the DEM editing focus window. Now, if we can all pay attention to the bridge as well, when I perform my edits, we're going to see some change. So I have a DEM editing operation already selected. It's called Opposite Ends Fill. What the opposite ends fill operation does is it will examine the selected polygon. So we're going to select our the first polygon we created, and look at each of the ends to find the average elevation for each pixel values along the edge. And then with those two elevations, it will then interpolate all along the length of the polygon. So I'm going to run our first operation, and I'm going to apply with overwrite. So it's going to remove all the polygon values here. And as I run, we see that there's a shift in the Live Ortho Preview. I'm then going to select the bridge polygon and run the same operation. And we can see that there's a change. Now, of course, there's this one little artifact, but we can cycle through all the ortho images and see that one of the ortho images looks acceptable for our use. Now, it's important to note that the edits we're making will need to be QA'd in the final outputs as well. So we can see this bridge and one ortho is correct, but we must ensure that the mosaic also has the ortho displayed. So once this edit has been made, we can close the Live Ortho Preview. I can either save the project or the DEM, the DSM, I can save it through a files tree or through the DEM editor. And then we can perform our final filtering to produce the digital terrain model. which is displayed over here. This I will use for the ortho rectification. So once we've created our DTM, we can minimize and go to our next operation, which is ortho rectification or ortho generation. And I can open up the ortho window. I've already created the orthos, that's why it says orthos done in the available images, but I'm going to select all the ortho images for processing. So moving them to the image process window, browse to a new location. I can create another folder calling it ortho 2. Select OK, so it's going to create the new files. I can then choose the DEM we're going to work with, so I'm going to click Browse, go to our DEM folder, choose the DSM DTM file that I already created and filtered. Here I have the DSM and the DTM within the same file, so I'm just going to select the DTM file, click OK, and now I can generate all the orthos. Once the orthos have been generated, for the interest of time, I'm not going to generate them, but we can perform our Mosaic generation. Now, the Mosaic tool we've introduced in 2018 is a updated system. It provides users a streamlined Mosaic process from beginning to end, starting with a graphical wizard to assist the user in the preparation of the Mosaic project. And once the user has prepared their project, they are then redirected to the Mosaic tool for hands-on editing of their data. So we can access the Mosaic tool from either the Ortho Engine Mosaic processing step or through the Geomatica platform. If we select the Mosaic tool, it's going to ask to say, oh, I'm going to cancel that and just open up the Mosaic tool then. Just a second. There we go. So this is the Mosaic tool. I can create a new project, select new. Here we are encountering the first window for the wizard, where we can load in the source images. So I'm going to load in all the ortho images I already created. So go to the output data folder, ortho, and select all the ortho images, and I can drag and drop them. And we see all their footprints are displayed on the right-hand window. I can click next and go to the Mosaic definition part. Here I can choose the output Mosaic. I'll call this Mosaic. We can set the resolution, the projection, and the number of channels I want. Here in the Mosaic preparation window, I can select the type of cut line generation I want to employ, color balancing, and if I want to utilize any normalization. Once I've set the parameters, I can then create a preview, a low resolution preview of the Mosaic that will be generated to assess it, and then I can click Finish to continue on to perform my Mosaic editing. So I'm going to actually click Cancel and load in a Mosaic I've already been working through, just for the interest of time. And we can see that this is what's generated. We have the cut lines generated, color balancing has already been employed, but I want to take our attention to this little beach over here, and we can see that this image here is a little darker on the beach than the surrounding area. So we can fix this by either two things. We can edit the cut lines themselves, which I can access by selecting the cut line editor, selecting the image, and then actually reshaping the cut line dynamically to remove that darkened area. However, if I want to, I can actually leverage our dodging points, which is another feature with the Mosaic tool, which will perform localized color balancing for the area. So instead, I'm going to select the image, and I can leverage our dodging points located here. We have a number of different operations. We can either auto match to both sides, which will look at the pixel values from both images and auto match and blend both images together, or just do it for the single image by taking the statistics from the surrounding images. For this instance, I'm just going to choose auto match to single side and click, and we can see there's already been change. And I'm going to remove all the cut lines just so we don't see them, and we can see how when I throw in another dodging point, we're seeing that the color balancing is continuing. We can continue performing additional cut line editing and color balancing until we're satisfied with the result, where we can then go select source images and select add to mosaic, which will then process all the images into the final mosaic. So in this workflow, unlike other workflows where we would not have identified problems like in the bridge until we've generated the orthos, we can actually avoid that by fixing them in the DEM and seeing their fixes in the live ortho preview, so that when we get to this mosaic step, we won't encounter situations like that. However, we do have a number of post-mosaic editing tools, but I will explore that in my next demonstration.
Great. Thank you so much for that demonstration, Jason. So let me just pick up on that point and continue our explanation here. So now we are turning our attention to DSM True Ortho mosaicing using GXL. Just a quick note on GXL. So for those of you who don't know, PCI is traditionally known for its desktop software, which is Geomatica, but we have had now for quite a number of years GXL software, which is essentially a large volume production system. So it's a little bit different. It has a web-based interface, and you can see here on the left we have an actual web portal that we expose as part of the software for users to interact with the GXL software. But essentially why GXL is so powerful is because it can actually process large data sets in parallel. So you can see over here on the right, we have a number of processing servers, in this case 3, but there's really no limit in terms of how many processing servers you can add to the GXL. We've had customers add hundreds of processing nodes, even on the Amazon cloud. And then what you can also do is have quality assurance stations. These are essentially licenses of Geomatica to inspect the results, kind of like what Jason was doing in terms of checking the quality of the orthos based on the DEM and so on. Of course, all of the data resides on a server, which feeds into the different processing machines, and where the quality assurance stations can access the outputs of the processing. This is just another kind of screenshot of what the GXL Web Interface looks like. You can see that essentially it's a series of different types of, we call them jobs basically. So because it's very workflow centric, you essentially point to an input folder where your data resides. You point to an output folder where you would like to have output products created. And then you set a few parameters and you submit the job. Once you submit the job, what the software does is it goes and looks for which processing servers are available to take that particular piece of work and process the data and generate the output. So DSM True Ortho, the reason we mention it in GXL, as we mentioned, is we have optimized the workflow specifically in our GXL software to handle DSM True Ortho. Of course, one of the prerequisites that's very important is a high amount of overlap. So we typically recommend 80% forward overlap and 60% side lap, which is the data set that we're working with today. The PhaseOne data set definitely is suitable for that. And the other key requirement is the ability to extract the DSM at 1-to-1 resolution. So that is some key technology that PCI has developed over the last few years, which is the ability to leverage the semi-global matching method to extract high quality DSMs at 1-to-1 resolution with very few blunders and additional technology for merging the various DSMs that are produced with all of this highly overlapping data. To that end, you can see here that the individual DSMs, depending on how tall buildings are, will suffer from a few artifacts, mainly occlusions. So you can see some features are occluded because of the way the building is leaning. And the other problem, of course, is the just the incorrect positioning of the building with respect to where it is. So the lean itself and the occlusions. So what our merging technology does is it basically takes all of the values across all of the multiple DSMs, then it merges them to produce the best elevation value that's closest to nadir. And what that will do is give you a nice DSM, which is what you see on the right, that eliminates areas of occlusions and building lean. And because it's at one-to-one resolution, we can actually project the ortho directly onto this DSM and achieve some very good results. You can see here the difference between single look DSM versus multiple look DSM. In this particular case, I believe it's UltraCam, but definitely you get a much smoother result as a result of merging the multiple DSMs, as you can see on the right. Just to clearly illustrate the difference between DTM Ortho and DSM Ortho. So on the left, this would be a terrain model that was used to generate the orthos. There's nothing wrong with that product. It's a perfectly fine product. The only issue with it, I guess, is that more and more what customers are asking for is to have no building lean and no occlusion. So as you can see, these two tall buildings are occluding this parking lot behind and this kind of open area behind, and they're not in the right position. Whereas on the DSM ortho image, they are perfectly aligned with the base of the building, and it just provides a much nicer looking image to work with. So in terms of once the mosaicing is done, as we mentioned at the outset, the technology allows our customers to make interactive edits without having to leave the geospatial realm. So there's no need to necessarily go to Photoshop to make final touch-ups and edits. We have a series of tools, one of which is called the Smart GeoFill tool. So it allows you to copy and paste different parts of different images into final mosaic. So that was a little bit of what Jason was showing you with the live ortho. Here, what you can actually do is you can delineate an area and you can identify a problematic overpass in this case and paste in a different part of the ortho over that specific portion of the final mosaic. You could do things like fix overexposure or underexposure, and it's just a nice tool to perform some of those final touch-ups. Here's a bit of a more detailed example of what I was just describing. So you can see that this overpass, the current mosaic has this kind of duplicate copy of the actual overpass that's caused by the DTM that was created. So we could either fix the DTM, or what we could do is we can actually just cycle through the different ortho images, find the one that's fitting a little bit better, and paste it into the final mosaic. And as you'll see in Jason's demonstration, there's options for blending along this line that you draw, and there's different options as well for color balancing and for adjusting the contrast and the brightness before you paste it in. This is another example of an exposure correction. So typically concrete surfaces or white buildings tend to be overexposed. So you could run a exposure correction filter across the entire image, or you could do it interactively over specific areas. The whole idea is to preserve the radiometry in the areas that are not overexposed, but to improve the overexposed areas and specifically target those. So if I swipe to the next image, you can see that only the overexposed areas were corrected and everything else stayed the same pretty much. So I'm going to pass back to Jason again for our final demo, and then we'll move on to the wrap up.
Hello again, everyone. Let me just display my screen. Wonderful. So as mentioned before, just going to show DSM True Ortho. Wonderful. So as mentioned before, I'm going to showcase one of our many methods we can employ to perform some post-mosaic editing. But before that, I would like to showcase quickly the differences between the DSM and DTM mosaics. That as we can see that there is a difference between how the buildings are being displayed. Here is the DTM mosaic for that full bundle block of images that Kevin explored, and we can flicker this off and showcase the True Ortho. So, and we can see that there is a shift in the building lean. The building lean has been removed in the DSM True Ortho, and the rooftop positions have been correctly positioned compared to the DTM. So just a little quick example of the differences between DSM and DTM ortho mosaics. So to go to the last part of our post-mosaic editing, we're going to go back to that same bridge I performed the initial edits on. Turning off the DSM, we can see that the bridge, again, has some few blenders underneath the area in our final mosaic. Now, previously, we'd have to go back to the DEM, fix the DEM, regenerate all the orthos, and then create the mosaic again. However, we do not need to do that. Normally, we'd have to do that, but instead we can leverage the Smart GeoFill tool in conjunction with the DEM edit to dynamically apply fixes we make to the DEM to the final mosaic. So again, I've utilized the same polygons around the bridge using the DEM editing tool, but I've also opened the Smart GeoFill tool, and I've set the source to be the DEM orthos. This means that all the fixes we make to the DEM will then be dynamically affecting the orthos that are overlapping the same region, and we can then use that to paste in the edits to the mosaic. So again, I'm going to go and turn on the DEM, run the same operations. I'm just going to select the first one, opposite ends fill. I'm going to instead click apply. And so now we have the bridge. Turning it off, I can then create a DEM ortho around the area, or the polygon around the area. The system is going to process, just take a few seconds, and ortho rectify. Orthoing all 8 overlapping images based upon the new edit we made. Give it just a few seconds. Wonderful. And last one. Excellent. And now we can cycle through all the regenerated ortho images to see which is the best option. And here, number 6 looks quite nice compared to all the other options with our fix, as well, or 7 as well, but we're going to keep it with 6 this time because there's a nice match in between the divider. Now I can just easily click the paste button to paste the new fix in, copying, and then save to the new mosaic, and then close the Smart GeoFill, and now our fix is made. Of course, there's some color balancing we can work on. We can perform some additional color balancing with the Smart GeoFill tool as well by selecting the DSM, Smart GeoFill, again choosing the DEM orthos. It's just going to process again, but then we can fix that with the color balancing for automatically applied color balancing. Just a second. Wonderful. Wonderful. And now we can paste it and continue on. So these are just a number of different tools that PCI offers for editing the DEM and the mosaics to ensure the integrity of the final product.
Great, thanks Jason for that. So we'll move to wrap up now. I will just move to the next slide. So just summing up in terms of the key differentiators for those of you who are using other software or are familiar with other software packages, we think these are the things that make us stand out, and we'd be interested to hear your thoughts on it. We believe that we offer a more integrated workflow. Then there is less of a need to go in and out of different software packages. Everything is sort of nicely integrated. We do have, as you saw, the ability to scale based on the size of the project, whether that's hundreds of images or thousands or tens of thousands of images between Geomatica and GXL. We have the ability to automate and streamline the production using things like the Python API. We can definitely reduce the use of external software for touch-ups. We think that this effort is going to result in reduced manual effort, which is just generally a good thing. And of course, the ability to generate high quality DSM True Ortho products is increasingly something that is becoming part of requirements for new data collections and products to be delivered. And last but not least, we do offer competitive and flexible pricing. So if you're thinking of using our technology, whether it's Geomatica or GXL, we are definitely open to speaking with you and finding the right solution for your needs. Another poll just before the last couple of slides here. So we are interested to know, what is your biggest challenge with respect to processing your aerial imagery? So it could be that you're using multiple tools and you find that to be an inefficient workflow. Possibly processing is too long, so maybe you're unable to produce one-to-one DSMs just because it takes too long to do that with whatever package you're using. Perhaps you're having difficulty getting a consistent level of quality, which could be related to color balancing or DEM accuracy. The manual touch-ups possibly are costly and time-consuming, and maybe you just don't have the ability to produce true ortho products, which is hindering your ability to respond to RFPs or produce products for yourselves or for your clients. So I'll leave that open a little bit longer. Hopefully those answers make sense and are relevant in terms of challenges. And I'm just going to close that out and show you the results. So it looks like people are having several problems, and no one in particular is having one more than the other. So always room for improvement, of course. Aerial photogrammetry is a very complicated process, so we definitely feel your pain. So just a couple more notes on upcoming features. So we do continue to develop our technology to support aerial data processing. We have high quality tie point and GCP collection methods for aerial triangulation optimization. That is something that we're currently working on to improve, and that just helps with everything. It helps with DSM extraction, quality, the processing speed of our DSMs. You'll notice that the one-to-one SGM DSMs is something that's pretty unique to PCI. It's definitely challenging because it's very compute intensive, but we've optimized our code to make it possible to extract one-to-one DSMs from this type of data. We continue to improve the live ortho capability. As you saw, we previously had one-to-one ortho preview over smaller areas, and we've optimize that to be able to do it across the entire image blocks. So we are always improving these tools with every release that comes out. We have other webinars coming up on this specific topic of aerial data, aerial image processing rather. If you are looking for help, we recommend a few things. Number one would be to our dedicated support website. So if you go to support.pcigeomatics.com, you'll find our support zone, basically, where we have a number of materials available for you. You can search the support website for specific articles relating to your topic of interest. So for example, we typed aerial into our search tool here, and we got 30 different results. So it could be things like someone in the community is having a discussion about aerial, or there's a specific tutorial, or a video or something that's relevant to aerial has been found in this case. We do continue to offer these webinars, so we will be offering, our next webinar will also be focused on aerial data. We'll be turning our attention to ADS processing using GXL, and we also plan an additional webinar to go into more detail with DSM True Ortho in a little bit later on. You can download our software. There's a fully functioning trial. If you go to getgeomatica.com, You simply have to fill out a form. You'll be given a link to download the software. If you have any issues whatsoever in terms of downloading the software, just reach out to our support team. It's very easy, support@PCIGeomatics.com. So at this point, that ends the technical portion of the webinar, and we would welcome any questions that you have about anything that was presented. So you can type in your questions now, or if you would like to speak, if you have a mic set up on your computer, we're open to unmuting your line. You can ask us a question directly. Just raise your hand in the panel. Okay, so I'll just kind of go through a few of the questions, I guess, that came in. So one of the questions is how to create a DEM. So perhaps we didn't give the definitions correctly, but basically everything we've been talking about primarily is DSM. So the DSM, according to our definition, does include the vegetation and the buildings. Typically, that when we say DSM, we mean digital surface model. So anything that's above the surface, including trees, including vegetation, is included in that particular elevation model. So digital elevation model typically includes both DSM and DTM. When we refer to DEMs, we mean both DSMs and DTM. So hopefully we made that clear. It sounds like maybe we could have made that a little bit more clear, but our apologies. So we have another question about have we tried to generate the DSM from the NAPE imagery? So that's an excellent question. I am not sure that the NAPE imagery is available in stereo. I do know that some of the older data that's available on USGS, the aerial photos that have been collected, are provided in full stereo, and so those can be used to generate DSMs. However, the NAPE data that's available that I've seen on the Earth Explorer website on USGS is tiled ortho imagery, so it's not the raw data that we can use to leverage the stereo. We have another question about, can you use an external DSM or DTM, for example, derived from LiDAR data? The answer is yes, absolutely. That is very easy to do. So essentially, we didn't showcase it in this webinar, but we've created other material that's available on our support website and through tutorials where you can link the live ortho capability that Jason showed to an existing elevation model of your choosing. So you could take a raw LiDAR point cloud, interpolate it to a gridded surface, and then link that to the ortho preview tool, and then carry on with the same workflow. We have another question about linking ArcGIS with PCI. So I'm not sure specifically what is meant by linking. I can explain a couple of things. So one thing is, because Geomatica has the Python API, it actually becomes very easy to create a toolbox inside ArcGIS. So if you're talking about creating a toolbox that calls PCI technology, then the answer is absolutely yes, you could do that. You could do it that way. So for example, you could leverage the DSM extraction capability from inside ArcGIS. The other method would be to just create a Python workflow that is executed outside of Geomatica or ArcGIS and would leverage both capabilities. We've published several examples of that over the last several years. So it's very easy to integrate ArcGIS with PCI, absolutely. We have another question about extracting point clouds. I believe the answer to that is yes. So we can basically take the DSM and convert that to a point cloud. we can definitely do that. I've seen examples of that internally. I can't recall off the top of my head exactly how to do that, but I do believe that we offer that capability. We have a question about, are these features available as part of Ortho Engine or are they separate modules? So the way that our software works is we do have different modules to support kind of there's two different levels of modules. So there's modules that relate to the type of data that you're going to be working with. So typically our customers will work with aerial data, or they'll work with satellite optical data, or they'll work with satellite radar data. So it kind of breaks down that way. So if you're working with PhaseOne, you would need the satellite aerial data. Sorry, the aerial package, and then you would need to basically add on the DEM extraction module. And if you're planning to do the triangulation manually, then you don't have to buy an additional module. But if you want to leverage the automated methods for doing the triangulation, the tie points and the GCPs, then you would need another module for that. So what I recommend is, if you want a breakdown on the pricing, I notice a few people are asking about pricing, just get in touch with us, send us an email. You can reach out to marketing at PCI Geomatics. We'll point you in the right direction. If you have a specific question, depending on which part of the world you're from, we'll put you in touch. If you want to speak in your local language, we have resellers around the world who can help you as well. We have another question about, is there a limit for the number of images for an aerial photo project in Geomatica? So there really is no limit in terms of being able to bring data in. However, the limit starts to become apparent if you're waiting for the project to sort of, triangulate or extract DEMs and so on. It can be quite long. So generally, we like to say that Ortho Engine is suitable for, upwards of 1,000 or 2,000 images kind of maximum. And then from there, you're better off sort of breaking the project down into smaller pieces, or using something like GXL for handling bigger data sets. Another question just came in. Stereo images are possible. I'm not quite sure if that's a question or a statement. If you could clarify, that would be great. But basically, everything that you saw today was based on stereo image collections. So multiple images over the same location with a lot of stereo overlap is what we need to produce all of those elevation models and the True Ortho products. So I think with that, I'm going to close out the session. I'd like to thank you all for making the time today to be here with us. If you have any questions, don't be shy to reach out to us. You can send us an email at info or marketing or support. Any way you want to reach out to us, we'll be there to respond to you as quickly as we can. Thanks very much, everyone. Have a great day.